let's look at question B. The amplitude of a particle at x is equal to 0.4, x is equal to 1.2, and x is equal to 2.3. So they are asking for amplitude for a certain position over here. We have already determined where is the node and the antinode, but now they're asking for some place in between the node, some place in between the antinode. We are asked to find the amplitude. So let's try to do that. Okay, nothing too complicated actually. We already mentioned in the previous video that to determine the amplitude of the standing wave, you can determine it by using the front part of the standing wave equation, which is 2a cos kx, or for this specific example, it's 5 cos pi x. Okay, 5 cos pi x here, which is the front part of the standing wave equation, will be our amplitude of the standing wave. But because amplitude shouldn't be positive, it shouldn't be there shouldn't be a direction to it, it's just represent the maximum displacement. So it's better that we modulus it so that there will be no sign bothering us. Okay, we don't want any negative value for amplitude. Even though the negative actually means direction, but amplitude we don't really care about the direction. That's why we modulus it to remove all the direction element. Okay, so this will be the equation. So for x is equals to 0.4 cm, your amplitude of the standing wave at x is equals to 0.4 will be equals to modulus of 5 cos pi, your x will be 0.4 cm. Okay, remember that when you're keying into your calculator, make sure you do this operation here it's in radian mode. Okay, so make sure your calculator must be in radian mode. In radian mode. Okay, so if you perform a calculation, I believe you're able to obtain 1.55 cm for your amplitude at this position. So what it means, okay, this might be a bit of a stretch to sketch it here. Let's try at 0.4. Okay, so it means by when your x is somewhere in between here, because 0.4 is around here, right? You'll find that the amplitude at this position over here, the maximum that you can go at x is equal to 0.4. Okay, this is 0, this is 0.5. 0.4 is around here. The maximum displacement that you can achieve at this position here, which is over here or over here, the maximum will be what we said earlier, 1.55 cm. So we can say that, okay, another color. What color do we have left? Purple. Okay, so x is equal to 0.4, it's over here. So if we go find where's the maximum that can be achieved here, okay, this maximum here, you find that its amplitude of standing wave over here is equals to 1.55 cm. Okay, that's the idea of it. Okay, next question, they ask for x is equals to 1.2 cm. Okay, x is equals to 1.2 cm. Oops, it's in purple. So your amplitude of the standing wave when x is equals to 1.2 is equals to, again, you are going to substitute the x with 1.2. So if you perform your calculation, I believe you get 4.045 cm, okay, or 4.05. Okay. Okay, a much larger amplitude. Let's see whether it makes sense or not. Okay, again 1.2, where is 1.2? 1.2 is between 1 and 1.5. This is 1, this is 1.5. Okay, 1 is here, 1.5 is here, 1.2 is somewhere around here. So you can see that the amplitude is still actually quite a big amplitude we have here. Okay, let's write it down. If x is equals to 1.2, will be somewhere around here. So if you, no, make a mistake. Oh, this is difficult to erase. Okay, x is equals to 1.2 is around here. I'm sorry. x is equals to 1.2 cm is around here. So if we go find the amplitude at this position, very likely for us to find that it's a very large value, which is 4.05 cm. Okay, much larger than the 1.55 that we see here. Okay, next, last question. X is equal to 2.3 cm. If x is equals to 2.3 cm, this is question number 3. Your amplitude of standing wave when x is equals to 2.3 is equals to modulus of 5 cos pi 2.3. So again, substitute in using radian mode, you are able to find it to be 2.94 cm. Okay, so just a simple illustration. 2.3, it's around in between 2 and 2.5. 2.3 is around here. So if you find 2.3, you go look for its amplitude over here, you'll find that it's 2.94. Okay, so I'm not going to sketch it here. I think you get the idea here. Okay, so this is how we determine the amplitude of a particle. We use the front part of the standing wave equation, but we modulus it to remove all the direction element. So that's it for this question. Thank you very much.